this is the first of 4 optional modules in which I'm going to share a demo edit that I did of a student's work from a previous course. These modules are optional, they're not essential for the course, but it will give you a sense of how I approach editing an entire essay. Also, on these demo edits, I will be providing the text of the original essay. If you have enough time and you want to really challenge yourself, you could try to edit the essay on your own before watching the demo edit. The next thing I would like you to do actually is to pause the video and take a few minutes to read this first paper. If you've read it through once, it'll be easier to sort of follow my thought process on the editing. Now that you've had a chance to read through the paper, I'm going to walk you through how I would edit it. It has a lot of nice elements to the paper. So first of all, the beginning starts out really well. It's a great hook for the reader. It goes into this concept of uploading your brain into a computer so that you can live forever. That's a really cool concept. It's a nice hook, and hopefully that hooked you in as the readers out there to reading the whole thing. So I'm actually not going to touch that first paragraph. Then there's 2 things I'm going to look at when I'm editing a paper like this. I'm going to look at the structure and the organization, and I'm also going to look at sort of the line-by-line type of editing, making the prose clean and clear. So actually, the writing in this paper is quite clean. There are some minor line edits I'm going to do here and there, and there's a few places where I'm going to point out to the author that it's a little bit jargony and ask them to unpack some concepts for us. But as a whole, the writing in this paper is pretty clean. There's a little bit of organizational reorganizing that I'm going to do here, though. So one thing I'd like to see up a little bit higher in this paper, we get this nice hook in the first paragraph, but we don't get to exactly what this paper is about until the 3rd paragraph. So this paper is actually about a recently published study by Dr. Kevin Brigman. But we don't get to that main point of this paper until the 3rd paragraph. So that's a little bit too late because the reader doesn't exactly know what this particular paper is going to be about. The reader needs to know a little bit sooner on. We know it's going to be something related to neural circuit mapping, but we need to know exactly specifically what this paper is about and what the significance of the study is that the author is talking about. So we don't get that until the 3rd paragraph. So I'm going to move up a little bit from the 3rd paragraph. And actually, if you go all the way down to the end of the paper, the last paragraph, there's a really nice statement in this of the significance of Dr. Brigman's work. So I'm going to move that up and make this first sentence here the basis of the actual 2nd paragraph of the essay. So I'm going to delete this and pop this right here, because this is the essence of the study. This is the significance of Dr. Brigman's study. What did they do? Well, it's the first example of a relatively large neural circuit reconstruction. So I want to make that point right up the front. This is why I'm even bothering to write a paper about Dr. Brigman's work, because this is why it's important. So let's make that statement right up front. Don't wait till the end and kind of keep the reader in the dark about what this paper is about. State it right out front. And then we're going to need the details, of course, about the particular study. So I'm going to copy this whole bit about Dr. Kevin Brigman and his team recently mapped the connections between these different types of cells in the mouse retina. So I'm going to just pull that up. So I'm going to say, in the first example of a relatively large neural circuit reconstruction, Dr. Kevin Brigman and associates, I'm actually going to change associates to colleagues. Associates sounds a little bit too much like a law firm, so colleagues, recently mapped the connections between these 2 types of cells in the mouse retina. And I'm going to end the sentence there. Now there is a little bit of jargon here. We got these 2 types of cells, the starburst amacrine cells and the bipolar ganglion cells. So I think the reader might need a little bit more clues as to what those are. I'm guessing that those are neurons. So what did we say? Key neurons in the mouse retina. And we can put, with a dash, we can put the 2 types of cells in between a dash. So something like that. So that gives us a nice statement of the significance of the work. We get early on what this paper is going to be about. It's going to be about Dr. Brigman's study where he mapped the connections in the mouse retina. Then we get this statement about how Dr. Brigman's work solved a controversy about exactly how these cells are wired in a certain direction. Well, that's a really interesting fact. So this paper is also, this study, Dr. Brigman's study, was also very important because it solves a particular controversy. Now, one thing that's missing from the rest of this paper is we never get any details about this controversy. The author in the original draft just kind of dropped it in the last paragraph, oh, and it solved this controversy. But that's a really important point. So we're going to tease the reader with that early on, say, hey, they solved this controversy, and we can unpack that. We can give all the details of that later. So I'm going to ask the author of this paper to add a paragraph as the second to last paragraph where they give the specific details about how they solved this controversy. So let's kind of give the reader a little hint about it in the second paragraph, and then we'll go into all the details about it in the second to last paragraph. So I'm going to make this a complete sentence. The work solves, and I'm going to make this in the present tense because we're talking about this is the first example and it solves something. So I'm going to keep this all in the present tense as we're giving kind of the big picture significance of the work. Solves I'm going to add long-standing, maybe that makes it sound a little bit more dramatic, a long-standing controversy, if that's correct, about exactly how these cells are wired to be directionally selective. Now, I'm going to highlight something here. This are wired to be directionally selective. I can kind of guess what the author means here, but I think this is probably a place where a little bit cleaner, clearer, direct prose might be helpful. We can use a little bit more technical prose down in this paragraph that the author's going to add about the controversy later, but if there's a way to say it just slightly simpler here, if there's a way to make that prose just a little bit simpler, so directionally selective is a little jargony, a little technical. If there's a way to simplify the language there just a little bit, I'm going to leave that for the author and ask the author to try to do that in their revision. Now, we ended up leaving a little bit down in this fourth paragraph where I had cut the details about Dr. Brigman's study and moved it up here. I'm actually going to cut all of this because there really isn't anything in this remaining material that we haven't already covered elsewhere. So, they were trying to better understand the wiring. Well, we've already said it's about mapping the circuits. So elucidating cellular circuit. We've already said that in this second paragraph here. And this directional selectivity about the particular types of cells, that's already mentioned here. So actually, I don't think any of this is adding anything. So I think we can delete all of that information, get rid of that third paragraph. So now the second paragraph gives an overview of the paper and states the significance of Dr. Brigman's work, is sort of the big picture. Then we get to now what is the third paragraph, which is this whole paragraph about electron microscopy. Now we get an awful lot of details about electron microscopy here, and so one of the things I might ask the author to think about in their revision is to say, well, do we really need all of these specific details? So there's a particular type of electron microscopy, this serial block face scanning electron microscopy. And that's very important for being able to map these neural circuits. If you didn't have that technology, you couldn't do it. But Dr. Brigman and his colleagues, this paper that the author is describing is not the one who invented this technology. So they're putting it to good use, but we can see here that it was invented by somebody else in 2004. So we may not need quite all of the details. So I'm going to streamline this paragraph a little bit, cut a little bit of the details, and I would ask the author to, in their revision, think about, do we even need to give so many details about why this type of electron microscopy versus other types? So I'm going to move a few things around. So I'm going to state right from the beginning, because again, this paper is about Dr. Brigman's study. So let's state exactly what happened. Well, Dr. Brigman and his team used this type of electron microscopy to visualize the synapses and map the neural circuitry. So we can state that right from the beginning. So I'm going to say Brigman's team used this serial block face scanning electron microscopy. I'm going to move this up to here. And the author here did use an abbreviation, an acronym, SBEM. I'm going to let it go for this paper because it's the only acronym they used, and it is awfully long to write out serial block face scanning electron microscopy. But as I've mentioned before, do watch acronyms to make sure you don't have too many. So Brigman's team used serial block face scanning electron microscopy, And then what did they use it for? Well, they used it to visualize synapses and follow neural processes. So I'm actually going to change that first sentence a little bit to just go right into what Brigham's team used the electron microscopy for. So I've changed it a little bit, but I think it works. So they used it to visualize synapses and follow neural processes. That was the goal of this type of microscopy. So I've started specifically with what Brigham's team done, and then I can go into some of the details about the different types of microscopy if it's needed. I'm also going to cut where it says volumetric reconstruction. Notice this very, that's kind of jargony, of neural tissue using electron microscopic resolution is necessary to map neural circuitry. Well, I think we can just say, if we're getting into why we used electron microscopy at all, electron microscopic resolution is necessary to map neural circuitry. I don't think we need any of the other words there. So we can cut a few words there. Then we get the author introduces two types of electron microscopy, I think, to say, well, these types weren't used because they have various problems if you're trying to map neural circuits. So let's just point out why they don't work for mapping neural circuits and get rid of, for example, focused ion beam scanning electron microscopy. We don't need to say that it gives excellent quality images because it fails, in this case, to be sufficient for this particular problem. So we could just say it fails to process tissue pieces larger than 40 microns in diameter. And then I'm going to connect this to this next type of microscopy that also doesn't work for this situation. And transmission electron microscopy, it's problematic because it requires thin sections, thin samples that often succumb to the damaging effects of manual handling and section distortion. So this whole sentence then becomes the reasons that we don't use these alternative types of electron microscopy, if this is determined to be important enough to put in the paper. Thus, it's most prudent to use a method that images the block face directly and is capable of imaging large block faces. And of course, this technique that Brigham used, SBEM, provides both necessary components. So it's arguing why serial block face scanning electron microscopy is so important here, and telling you why other types of microscopy weren't used. All right, so I think that works. Of course, again, I would question whether we need even all of these details about why, one type of microscopy versus the other, but maybe that's very important. I'll leave that to the author to judge in their revision. Then we get to, okay, so this is what they use, the technology they use. Then we get to the details of this particular study. So we're sort of giving all the details of exactly how they reconstructed this large neural circuit and solved this controversy. The next two paragraphs actually are related to one another, and what I'm going to do is I'm going to shorten them a bit, cut out a few pieces of words and things that were a little repetitive, and actually can bring these two paragraphs into a single paragraph. I think they're related enough that it really all belongs in one paragraph. So it says, by staining a 200 micron piece of retina, which contained the entire arborization field, that's a little jargony right there. I think that has to do with the branching of neurons. I'm going to highlight that and in the revision encourage the author to see if they can come up with a simpler way to say that. I know that's a technical term in the field, but remember you're writing for the whole class. So that has something to do with branching of neurons. Maybe there's an easier way to say that. I'm also going to make a few edits to this sentence. So of a starburst cell with an extracellular stain that could outline cells and neural processes in SBM. This is kind of a long sentence. I'm going to just notice that the author writes by staining with an extracellular stain. I thought maybe we could change that to treating. So I said Brigham's team treated a 200 micron piece of retina. To get rid of a word here, instead of which contained, I'll put including the entire arborization field of this particular type of cell. And I'm going to set that little extra detail off with commas here, because we could actually, you don't need that whole detail. We could just say Brigham's team treated a 200 micron piece of retina with an extracellular stain. So this is just an extra little detail. So it seems like an important detail, but we can put it in with commas, set it off with commas. With an extracellular stain that could outline cells and neural processes in SBEM. I think neural processes probably needs a little bit of unpacking too. I'm going to highlight that for the author. It's a little jargony. Is there something, could you explain it kind of quickly with some simpler terms there? And I'm going to end the sentence there. So Brigman's team treated the retina with this. They were able to outline the cells and neural processes using this extracellular stain and this electron microscopy technique. Next we get to, we don't need to say Brigman was then able to reconstruct neural processes, right? That's repetitive, so we can just cut that. Then we get this sentence, based on morphology, he assessed the locations and sizes of putative synapses on these processes. All right, well, basically the idea here is that he's inferring where the synapses are based on what he can see. He can't see the synapses, but he can see shapes that suggest where the synapses might be. So I actually like better than assessed. Here's a really an example of using a good verb. I really like the word inferred here rather than assessed. That's what he's doing. He's inferring where those synapses are based on this morphological data. I don't think we need to say a putative synapses on these processes. I think we can delete that and we won't lose anything. In the next sentence that's in the next paragraph here, it's talking about why he has to infer. That is, why he can't directly see the synapses. So basically the synapses have intracellular features and the stain is an extracellular stain. So I thought actually that this whole concept is directly related to this sentence about inferring where the synapses are. So I thought we could kind of tie this all together. I actually want to put the idea in first, so the need to infer comes in first. So we could add, due to their many intracellular features, I'm just bringing this concept up from below, Brigman's team could not directly visualize synapses. I think that's the idea. So I'm trying to say it just slightly more directly than the author had in the original version. So because they have many intracellular features, and this is an extracellular stain, which we've just said in the previous sentence, so we don't need to repeat, Brigman's team could not directly visualize the synapses. And I'm going to add here what a synapse is, a neural connection, maybe a little kind of simple explanation in parentheses in case a reader doesn't know. So now we've gotten rid of all of the material in this. We don't need to repeat that. And then this transition in an effort to address this ambiguity, I don't think we need that either. So due to their many intracellular features, Brigman's team could not directly visualize synapses. I'm going to add the word but here. But, so they can't directly visualize them, so they're going to infer them. But based on morphology, he inferred the locations and sizes of putative synapses. I'm actually going to change that to they, because it's not one person that was working on this study, it was a team. So let's keep it to team and they. They inferred the location and sizes of the putative synapses. And then I'm going to just wrap this around and again include it in this paragraph here. They also stained a second piece of tissue with, and I'm going to add, they stained a second piece of tissue with an intracellular stain. I'm inferring this. I'm guessing that they must have used an intracellular stain because they were able to stain those intracellular features. So they also stained a second piece of tissue with an intracellular stain that revealed synapse-associated features. In the original sentence, there was they stained and then synapse features were stained, so there was a repetition of stained there. So I think this works just a little bit more smoothly. So they also stained a second piece of tissue with an intercellular stain that revealed synapse-associated features. And then there's this last thought here. I'm actually going to pull this and to make this a complex sentence. So they did this experiment with the second piece of tissue to reveal the synapse-associated features. And I think the idea is here to try to use that information to confirm what they found with the first stain based on morphology. So I think we can tie these two ideas together with a semicolon. And they correlated, and I'm just going to say they correlated the synapse maps, because we're getting a synapse map that we guessed at using morphology with the first stain, and we have a synapse map based on actual intracellular staining with the second piece of tissue. So we can say something like, and they correlated the synapse maps between the first and second piece of tissue. We can kind of get rid of a few extra words there, and I think synapse maps is sufficient. Again, I'm going to ask the author to then add in a paragraph here that goes into that controversy that they solved about the directionality of the particular cells. So explain that a little bit more for the reader. That seems like a really important part of Dr. Brinkman's study, so let's get some details on that. And then we get to the last paragraph. The last paragraph has a nice thought. It's tying up kind of where we started, right? So we started on this whole idea of uploading a whole brain onto a computer, and we're getting back to that in that last paragraph. So I'm just going to tweak it a little bit to even bring out that connection, to kind of wrap back to the beginning even a little bit more strongly, to have a nice finish. And I'm going to just tweak a few things in the language here. So notice that there's a few, the last sentence has a little bit academic because we're getting a lot of nouns like reconstruction, preparation, imaging, mapping. Those are all nouns that could be verbs. So I thought we could streamline this a little bit by turning some of those nouns back into verbs. So the next steps in whole brain circuit reconstruction, I'm going to leave the reconstruction, will be, and then let's, instead of saying large sample preparation, we don't need to say large sample because we're talking about whole brain, so that's sort of implied. So will be to prepare, see, not preparation, but prepare, be to prepare, to image, rather than imaging, to image, and map, to prepare, image, and map the first, or and map the whole mouse brain using SBEM, that type of microscopy. So I think we can condense all of this in imaging and mapping on a whole brain SBM for mapping the whole mouse brain. I think we can get rid of all of that and just say the next steps in whole brain circuit reconstruction will be to prepare, image, and map the whole mouse brain using SBEM. So I think that's a lot cleaner and faster, and you're using those good verbs there. You can get the whole idea across much more quickly. And then we want to say that this is the first mammalian complete connectome, and I'll leave that term connectome in there. It's a good buzzword these days, so even though it's a little technical, I think most people are familiar with the buzzword. So we could say this would represent the first mammalian complete connectome, so that's getting to the idea of the whole brain, all the connections in the brain. And I'm going to add that little last thought that ties us back to the beginning, and would be the closest anyone has ever come to immortalizing, so I'm tying back to that idea of immortalization, a mammalian brain. So I think that's probably a fair thing to say, and it just kind of is a nice ending that ties us back to the beginning. So I think this paper was reading really well. I've done a few little things to streamline the writing here and there, condense a few things. I've changed the organization just slightly. I'd go back to the author and say for the revision, all those words that I've highlighted, probably see if you can say it a little bit more simply, or in passing give a little definition for the readers, especially who aren't coming from neurology. Add a paragraph about the controversy that was solved. And other than that, there's not too much else to do on this one. Maybe go back to that electron microscopy paragraph and see if there's any details that could be cut there. But I think it's reading really well. It was a really good paper to start with, and hopefully going through the editing process like this has been helpful for your own approach to papers.